This session is on Math 31 Pre-Calculus. And if you look over your booklet, if you've been engaged in it at all, you'll see that some of the sections are really a repeat of Math 30-1. The first section on inequalities and absolute value is really the section that we're going to spend some time on, which we have done back, believe it or not, back in Math 20-1, sorry. And then we're revisiting it in Math 31. The other sections, I don't find students have quite as much trouble on, so I thought I would choose some of the examples that notoriously kind of give us a little bit of grief. So the first question that I'm going to do is from the instruction booklet. It's on page 10, just if you want to refer to it. And it's number 4, practice. And the question says, x minus 3 over x plus 5 is less than or equal to 3. And we're going to solve this. So there are a couple of ways of solving these. We can leave the 3 on the far side, and we can manipulate and work with them. One of the more common ways to do these inequalities with the rational on the left-hand side is to make it equal to 0, or get a 0 on the other side, not equal to 0, but get a 0 over there, manipulate things a little bit, and then do the cases. So that's the method that I'm going to choose to show you. So we're going to have the x minus 3 over the x plus 5. We're going to take away 3 and leave a 0 on the far side. And what that sets up for us is doing some common denominator work here. So we're going to have to make sure that the minus 3 has a common denominator of x plus 5. So not terribly hard work, but just be careful. I'll lead us through here. We're going to put x plus 5 on the top and x plus 5 on the bottom. Whoops. And not equal to 0. Sorry about that. Less than or equal to 0. So again, what we do to the top, we do to the bottom. And then we just kind of push our way through here, distribute the bracket on the top, the minus 3, put a common denominator on the bottom, and then work a little further. Minus 2x minus 18 over x plus 5 is less than or equal to 0. Now, I see that we could do a little bit of reducing on the top. Now, you don't have to do this step, but I'm going to throw this in. So I'm going to take a minus 2 out and get x plus 9 in the bracket like that. And then we're going to divide by minus 2. And let's just remember the little rule that if we multiply or divide an inequality by a negative, we reverse the sign. Reverse or flip the sign. So we're going to get x plus 9 over x plus 5, and then we're going to get greater than or equal to 0, because dividing the 0 by minus 2 just leaves it as a 0. Now we have to stop and consider what are the cases on the left-hand side that would make the expression greater than or equal to 0. So we have to, in other words, we have to make the right-hand side positive. This is the thought process. If I could draw a little, whoops, that's supposed to be a thought bubble. That did not work. A light bulb. Ooh, a light bulb. What do we have to think about? We need the left side to be positive, basically. So the only way the left side can be positive is if the top is positive, the bottom is positive. Positive divided by positive is positive. Or if the top is negative and the bottom is negative, negative divided by negative is also a positive. Okay, so let's do the two cases. Case 1 is x plus 9 is going to be greater than or equal to 0. And x plus 5 is going to be greater than or equal to 0. Put the word and in there. Solve these two little things. So we're going to subtract 9 from both sides. Get x is greater than or equal to minus 9. Subtract 5 from both sides. Get x is greater than or equal to minus 5. And then what we have to do here is we have to reconcile. So now the word reconcile means find where these two things overlap. We're looking for the overlap in these. So one good way that we can do this is we can do this on a number line. So we have 0, minus 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's minus 9, 2, 3, minus 5. So the first one, and I want to do some color coding. Let's do this guy. I'll kind of highlight it in yellow once I get it. So close dot, arrow going that way. So that's this guy. Then the next one is, and we'll just do it with a different color. We'll do it with green. So we're going to graph it. It starts at -5 with a closed dot. 1, 2, 3. Make sure my graph is right. With the arrow going that way. And if we put that same yellow on it, whoops, I thought I had changed the color here. That did not work out very well. Let's change the color here. Technology is so great. Like that. Then this guy is going to start here and go here. So we're looking for the overlap. This is the overlapped section, and it goes on forever that way. So we can see that, therefore, our answer here is going to be x is greater than or equal to -5. Now, in interval notation, which we haven't had a lot of experience in interval notation in Math 31, I'm going to take a little moment when we're done this question to make sure you're clear on it. We could write it in interval notation as -5, infinity, where this was a square bracket and this was a round bracket. Again, we'll flesh that out a little bit in case that's a little hazy to you as to how we change from something that's sort of somewhat in set notation, it's not perfectly in set notation, down to interval notation. So again, we're looking for the left side to be positive. So positive, positive does it. Case 2 for us is when x plus 9 is going to be less than or equal to 0. And x plus 5 is going to be less than or equal to 0. Both of them are going to be negative. So we're going to subtract 9 from both sides here again. Get x is less than or equal to -9. Subtract 5 from both sides, x is less than or equal to -5. So again, we have to find out where the overlap is in these. I don't know if the color coding added a whole bunch to our discussion or not, but 5, 6, 7, 8, 9. I think it's kind of nice. So 1, 2, 3, 4, 5 here, and 6, 7, 8, 9, 9 there. So we'll do the same thing. I'll use the yellow for the 9. Less than -9. So we have -9 here and less than going that way. So that's kind of the first solution. The second solution, again, I'll just use the same color, a highlighter, is going to be highlighted in green once we have it. So we have a closed circle here, and I'm just going to draw it a little higher going down that way. So it looks like this. So again, looking for the overlap area or section is there, going down that way to the -9. And so therefore our overlap here is x is less than or equal to -9. In interval notation, again, we start with -infinity because that's like the smallest number it would get to -9. Circular bracket there, square bracket there. Now we put these two answers together and we're done. So we're kind of wrapping up the question. So the final answer for this guy, and I like to go smallest to largest. So I go -infinity, -9, union -5, whoops, got to be cautious of get the right bracket there, square bracket, and then positive infinity. So that is the final answer. I'll put a little box around it. Okay, so for this particular course, they do have us kind of change from set notation to interval notation. As I mentioned, we haven't done a lot of interval notation. If you come through the -1 stream all the way, you won't have been exposed to it a ton. So before we go and do our second question, which is quite a long question, it has 4 cases and gets a little bit intense. Let's make sure we're clear on set notation and interval notation before we do that. So just grab ourselves another nice clean piece of board. Let's talk a little bit about set notation and the particular important things. Set notation is always set up like this. I'll just make up a statement and we'll talk about what it says. We always have these set brackets. And then we identify whatever the letter is that we're using. You don't always have to use X, but oftentimes we use X. If we're reading it, we read as such that. not super important that you know that. This is the actual kind of the answer, whatever the restriction is on it. And then we always have to write the number system. Now you should have had a little bit of exposure to number systems. Oftentimes for our course, it's going to be real numbers. You might have integers. There could be a variety of things. Could have whole numbers. Really, most often, it's integers, okay, or real numbers. I'm sorry, it's most often real numbers, the ones that I just underlined there. So those are the important components to set notation. I don't think that really catches anyone too much off guard. Now, interval notation, it's actually kind of a bit easier. However, you need to note it only works for real numbers. So that is sort of a problem. If you're having to write something that doesn't have real numbers, you can't use interval notation. But if I was trying to convert x's greater than 2 to interval notation, we start with the lowest number. So it always goes lowest number, comma, highest number. And then we either use circular brackets or square brackets. And we can have an intermix of both. Lowest number, highest number. The difference between the brackets is that the number is not included if it's round brackets, and if it's square brackets, the number is included. So for example, in the example we got up there, x is greater than or equal to 2, we'd start at 2, make a comma when we do infinity. Now, infinity, we always use a circular bracket or a round bracket because we don't really know what infinity is. It's not really a defined number we can touch. Okay, so we always use a round bracket. So interval notation is not super hard, actually quite a lot easier than all the bits and pieces surrounding set notation, but we only will have it work for real numbers, so then that's kind of a drawback. Okay, now the last question, let me find a nice piece of board here because we're going to need quite a lot of room for this guy. Let's get up and over here. Okay, it's coming from your instructional booklet. It is example 8. Yeah, example 8 from page 11. I'm just going to grab that out so I can put it up there and talk about some of the important little pieces here and try to stress kind of the details. The math is not all that hard, but it's really kind of tricky. So let's get this question out here. So it says solve and graph. I actually don't think I was going to do the graphing part, but maybe we better do the graphing part. Solve and graph. And it says the absolute value of x minus 3 over the absolute value of x minus 4 is greater than or equal to 6. Okay. So before we start and do any work on it, we are always going to cross multiply. And I've been looking over how to do these. We always want to cross multiply so we don't get into trouble with multiplying by a negative and figuring out whether we have to, change the signs or anything. So if this is kind of one way to write it, we're going to rewrite it and kind of deal with all of our work. Whoops, change the sign magically. X minus 3 is greater than 6 times the absolute value of x minus 4. Okay, this is what we're going to use in our cases as we go through. Now, because now all of a sudden we've added in absolute values on top of the rational expression part of it, we have 4 cases. We have the top being positive and the bottom being positive. The top being positive, the bottom being negative, and vice versa, top being negative, bottom being positive, and the bottom being negative, top being positive. So we can do a little chart. I'm just going to kind of show you. I don't usually do this chart, but I do notice that students do like doing this little bit of a chart to get them an idea of what to do. So I'm going to write this down, but I'm going to really flesh out how I prefer to kind of have it done. So we have that x minus 3 and x minus 4. So we can have this being positive and this being positive, this being negative and this being negative. And then we can have positive, negative, positive, negative. I want to do it in a little bit different order. I want to do it in the order I usually. Positive, 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 negative. Doesn't really matter. Negative, positive, negative, negative. Okay, so those are our 4 cases that we're going to look at. Now, as we go through, I'm going to try to give you some kind of generally, this is what we do. We start out kind of step 1, and we find the restrictions on both expressions. And then we reconcile. Reconcile means find out where they overlap. And when we reconcile those. Step 2, we solve the expression. In step 3, we take the answer from step 2 and we reconcile back to step 1. Okay, so again, just in general layman's terms, we find the restrictions and then we reconcile them and we get one kind of starting restriction. We do the solving, the math, we take the answer and we compare it back to the start and we see where those overlap. You have to be very, very cautious and careful how you show your work so that it's all there and nicely laid out. I don't find this table near enough information. It was kind of a start. So I'm going to break out the 4 cases for you. Okay, so case number 1. I'm going to write it all down like out in glowing detail to make sure that you can see exactly how this goes about. Okay, so when we're looking at positive and positive, we are simply going to write down that we have x minus 3 is greater than 0, x minus 4 is greater than 0. Solve both of those and get x is greater than 3 and x is greater than 4. Just added 3 here and added 3 here, added 4 here and added 4 here. Now, just like we did a minute ago in that last one, we reconcile. Now, I don't need to see a number line if you're doing this for some sort of assignment question, but I do need to see something about therefore the first restriction is. So somewhere indicate what you do with these. I don't mind. I actually kind of like the idea of the number line. But you decide what it looks like. So it's an open circle going that way. It's an open circle going that way. I will put a little kind of square. This is the overlapping part here. So therefore our starting restriction is x is greater than or equal to 4. Now we're going to go and solve the question. So that means that we're going to go back, see the question up there. And since we picked positives, we're simply dropping the absolute values because we're not going to put negatives anywhere, and we're going to solve that. So our statement, I'll just make sure that stays on the top of our board, is x minus 3 is greater than 6 times x minus 4. So this is kind of step 2, okay? And I could number these, step 1, step 2. So we go x minus 3 is greater than 6x minus 24. Have to do a little bit of reorganizing of sides. So subtract 6x, subtract 6x. We get minus 5x minus 3 is greater than minus 24. Minus 5x, oops, plus 3 on both sides. Minus 5x is greater than minus 21. Now we have to be careful. We have to divide by a minus 5. So we divide by a minus 5. And then it doesn't matter to me how we write the final answer here. I find I'm going to look at the book here and see what they say. I kind of like it as an improper fraction. They don't write it that way. They don't write it as an improper fraction. So, oops, I forgot to reverse my sign here. I said it and I didn't do it. So divide by minus 5 and then reverse the sign. So 21 over 5 works totally cool. You could also write x is less than, what is that, 4 and 1/5? Yeah, 4 and 1/5. Okay, that's step number 2. Now, step number 3 is you have to take that answer and overlap it with the original answer and see if there's any overlap. Sometimes there's no overlap, sometimes there is. Okay, so step number 3, we're going to take x greater than 4 and x is less than 4 and 1/5, and we're going to figure out what the overlap is. Again, if you want to do a number line, it's a very nice, clear way of showing me, the teacher, what you're doing. So it's going this way. 4 and 1/5 is right here, going that way. So it's between these two. Okay, so it's from 4 to 4 and 1/5. So again, they like things in interval notation, just makes life a little bit easier. So we write our answer here as therefore we've got 4 to 4 1/5. So that is our first answer to case 1. So I'm not trying to quibble. These are easy questions. They're not, but they're not super complicated, not super difficult math, but kind of intense in terms of the ins and outs. So that's case 1. We're going to zip back up here and kind of move over and do case 2 right here. So remember case 2, I had said we're going to have a positive and a negative. Okay, so case 2 looks like this. Step number 1, x minus 3 is greater than 0. X minus 4 is less than 0, right? Positive, negative. Yeah, that's what I said we're going to do. Add 3, add 3. X is greater than 3. Oops, goodness sakes. Sorry about that. Add 3 here. The next one, we're going to add 4 to both sides. Add 4, add 4. X is less than 4. So here we're looking for numbers that are greater than 3 and less than 4. Again, I'm going to stay with the number line idea. So 1, 2, 3, 4. This guy's open circle going that way. This guy's an open circle going that way. So your overlap is this little section from 3 to 4. So we say here, therefore, I'll change my color here. The answer is 3 to 4, and I'm putting it in interval notation. Okay. Now we actually solved it. So the expression is x minus 3 is greater than 6 times x minus 4, but we decided we're doing minus for a negative for the x minus 4. So we have to put a negative. I stick it outside there. Okay, so there's where the negative goes. Now we solve it. X minus 3 is greater than minus 6x plus 24. Add 6x to both sides. We get 7x minus 3 is greater than 24. Add 3 to both sides. We get 7x is greater than 27. Divide by 7. X is greater than 27 over 7. Again, they do seem to want to change it to mixed numbers. So it's 3, 21, 6/7. 3 6/7. Step number 3 in case 2 then is to reconcile. So we're going to look at the first one was 3 to 4. And then this one is x is greater than, I won't put a bracket there, don't need a bracket there. X is greater than 3 6/7. So we have to look at that again. Let's spread this out. This is 3, this is 4. So we have an open circle and an open circle. Now 3 6/7 is kind of here somewhere, and it's an open circle going that way. So the overlapping piece is here from 3 6/7 to 4. So therefore our final answer in here is 3 6/7 to 4. And again, I'll put some highlighter. Okay, remember when you're watching this, you can pause it, you can go back. I'm trying not to go too super quickly here as you're going through. Make sure that none of my numbers get messed up. So we've done 2 of the 4 cases. The green answers are our final answers. In each case, remember that we do 3 steps, right? We do the starting restrictions, we reconcile, we solve, we take the ending answer, we reconcile with the start. Okay, my next one was negative and positive. Okay, so I'm gonna make it a little bit tinier so we can keep a little bit on the board before I move down out of the way. So case 3 is going to be that x, what did I say? Negative and positive, right? X minus 3 is going to be less than 0, and x minus 4 is going to be greater than 0. And just for ease sake, I'm going to write this down where we're working so we can see what it is, so we don't lose touch with it. So the question, because we're going to go down here, the question is x minus 3 absolute value is greater than 6 times the absolute value of x minus 4. So let's just put a little circle around that. That's the question. Again, kind of carried down. Okay, off and running. Step 1. Add 3 to both sides. X is less than 3. Add 4 to both sides. X is greater than 4. So draw number line 3 and 4. We're looking for numbers less than 3, greater than 4. There's no overlap. Therefore, this is awesome, sort of. There's no solution, we're done. We don't even have to do step 2 and step 3 because we didn't find any overlapping. So that's wonderful. Oftentimes you'll have one case that'll, don't have to do any work. There's no overlap and we're good. Okay, last case, case number 4 then. Take a sneak peek. It's negative and negative. Oh yeah, I should know that. So step number 1, x minus 3 is less than 0. X minus 4 is less than 0. Could have the word and in here because we're going to look for both things. Anyway, that's a minor detail. Plus 4 plus 4. So we get x is less than 3. X is less than 4. So we're looking for where that is overlapping. Again, do our nice little number line. X is less than 3 looks like that. X is less than 4 looks like that. Therefore, our overlap is from 3 down. So in terms of interval notation, it's minus infinity to 3. Or we kind of can interchange x is less than 3. It doesn't really matter. We're going to write our final answers in interval notation. Okay, now this time, look at the equation over on the top left of the board. We're going to take each of those, put them in brackets, put a minus out front. So the x minus 3 is going to be put in a bracket with a minus greater than 6. And then the x minus 4 is going to have a minus. And I'm actually just going to sneak the 6 over a little bit and tuck the negative in front. So there's our 2 negatives. All right, let's solve that. Minus x plus 3 is greater than minus 6x plus 24. Add 6x to both sides. We get 5x plus 3 is greater than 24. Subtract 3, we get 5x is greater than 21. Divide by 5. X is greater than, 21 over 5. Now, if we change it, stay with kind of our theme, that's 4 1/5. Okay, so let's have a look at that. Now, did I make any boo-boos and things? Take that over 5x, 3, take 24, 21, greater than, something doesn't seem like I'm right. I think I'm good, but okay. So let's reconcile these guys. So we got less than 3. So let's take these. So this is step 2 here again, step 3. We're going to do this, and x is less than 3. So 3 is here, 4 is here. X is less than 3 goes like this. Greater than 4 1/5 goes like this. Therefore, there's no solution here on this one too. Not too often that we get 2 sections that have no solution. Okay, so here's our 4 answers. We get two solutions here and no solution down at the bottom. So then we just put everything together in terms of an answer. See if I can make this small enough here so we can just see all, no, not quite. Maybe there we are. Okay, so 4 and 1. So those are our 4 answers. We've got 2 no solutions. So we're going to take this answer down here and this answer down here. So I'll make it a little bit bigger there so we can just see, because we can see we got 2 no solutions. Okay, so we got 4. Oh, we're going to start with the smaller one. Okay, so we're going to start with the 3 6/7, comma 4 union 4, comma 4 1/5. And we can't really combine it any further than that because the 4s are not included. So it's from 3 6/7 to 4, and then kind of a little gap, and then from 4 to 4 1/5. Basically, 4 is not included. So we go to graph that. Now be careful when we're graphing it. We're graphing it on a number line is what we're looking at, because we don't have 2 letters here. We only have 1 letter here. So let's spread it out 3, 4, 3 and 4. I guess we really just need between 3 and 4. So 3 6/7, we should make sure that's on there. And then 4 1/5. This is kind of a weird answer. We're going to have an open circle with a ray, like a line segment that goes here with another open circle, another line segment, and another open circle. Really kind of an interesting solution to this question. This is the overall solution to this question. Okay. So just one more look at it. I think I can make it small enough so we can sort of see. We'll go back through and I'll make it a little bit bigger and we'll just kind of summarize. So when you're doing these absolute values, it's key that you cross multiply first here, get it in this format, and then you can lay out the cases so you kind of have them to look at. Generally, you're finding a restriction at the beginning, 2 of them, reconciling, solving, and then taking the answer from the bottom and looking back to the top one. And so you'll see that the 4 cases outlined here. And then we wrote our final answer and we graphed it. So hopefully that was helpful on the first section of pre-calculus in Math 31.